at least one on there with good voice. Okay. This is called rectangular. Okay, X, Y, we've all seen that's on the Cartesian plane. We all feel good with that, right? Okay, polar comes in the fashion of R theta. What do you guys think R stands for? Radius. And this is an angle in radians. So we have our radius. Did you try it? I don't know, but it's kind of like has a little kick in it, huh? No, definitely not great. Okay, so let's write an equation. R equals 4 sine theta. That's an equation in polar. Notice it's in terms of R's and thetas, right? We're going to graph that. Now, when you graph in polar, you need to have circles. Because guess what that circle represents? Radius 1. That's a circle with radius 1, would it not? Okay. This is a circle with radius 2, 3, oops, that one's not as pretty, and 4. Everybody get the idea of what I'm at least doing and trying to achieve here? Okay? All right, so let's go ahead and do a T-chart. Notice R is dependent on theta in here, meaning if I plug in thetas, I'll get R values. What theta value should I plug in first, do you think? 0 is a nice one, isn't it? Okay, I'm going to switch my color since that's purple on this. So I plug in 0. Sine of 0 is 0. 0 times 4 is 0. So notice I'm right here at the origin. 0, 0. 0 radius and 0 degrees. I mean 0 radians. Everybody got that? Let's plug in pi 6. Now, you could pull yourself up online. I'm not going to get it for you, but if you look up online, polar graph. And it's a nice thing to have if you want to pull those up, because all these lines right here, so give me 1 second. So all these lines, whoa, Betsy, where'd you go? Notice this line right here, not that line. Okay, that's the XY axis. Does everybody see that? Notice this right here is, so this right here is pi thirds, that's pi sixths, that's pi halves. Does that make sense? Not pi halves, pi fourths. With me? Okay, so what happens is I'm going to go on an angle of pi sixths. Notice when I plug it in, what's sine of pi sixths? There's a half, right? Sine of a half, sine of pi 6 is a half. A half times 4 is 2. So I come out here on this line, and I'm going to put a dot on that line at where? Radius 2. Does that make sense? Bye, Nene. Yeah? Okay, let's do pi fourths. Okay, what's sine of pi fourths? Root 2 over 2, correct? Root 2 over 2 times 4 would come out to be 2 root 2. Can somebody put that in their calculator really quick for me and tell me what it is? Okay, so really a little bit before 3, huh? You guys agree with that? So at pi halves, which is the halfway, I'm going to come out right before 3. So do you guys see that dot right here? Do you guys agree that would be on pi fourths? Yes? Okay, now we're going to do pi thirds. Okay, pi thirds. What's the sine of pi thirds? Root 3 over 2. 4 times root 3 over 2 is 2 root 3. Can somebody do 2 root 3 for me? I believe it's around 3.5, but I'm not sure. Okay, so 3.46. So here's pi thirds, 3.46, somewhere right there. Yes? Feel good? Okay, so once again, I'm on the angle of pi thirds. With me there, Hat? Notice 2 root 3 was 3.5, so I'm going to go out 1, 2, 3.5. So that's where that is right there. Good on that? Feel better? Okay. Then where are we going to go? Pi halves. Everybody agreed there? Pi halves? Okay, what is the sign of pi halves? 1. 1 times 4 is 4, so it's right there. So far, this is what I have. It's not very pretty, but we got the idea. Okay? We're going to keep going. What else should we pick? How about 2 pi thirds? Yes, no, maybe so. Feel good? 2 pi thirds. What's the sign of 2 pi thirds? A half. A half of 4 is... No, it's not a half, is it? It's root 3. So, root 3 over 2 times by 4 is 2 root 3, and we already found that out to be 3.5-ish, right? So here's our angle. 1, 2, 3.5, so roughly right there. Anybody having a question how I'm plotting these points? Okay, let's do 3 pi fourths. That's going to also give me 2 root 2, which you guys said was 2.8. Then I'm going to do 5 pi 6. That gives me 4 times a half, which is 2. Okay, and then I'm going to do pi. Sine of pi is 0. 0 times 4 is that. So on this line, I'm at 0 again. Now that's not very pretty, but guess what that is? It's a circle. The reason why it's not so pretty is I hand-drawn my radiuses, right? And I was kind of going in increments of what I believed was the axes of pi thirds, pi sixths, and pi fourths. Yes? Okay. Now what if I continue on? What if I did 7 pi sixths? Okay. That's how you feel right now? 7 pi sixths. I actually don't have to even plot this and I'd still get the same graph. But when I plug it in, sine of 7 pi 6 is -1/2 times 4 is -2. Now what is this -2 representing? The radius. Is there such thing as a radius of -2? No, so here's what happens, ladies and gentlemen. Okay, here is the angle of 7 pi 6. Now it's not very, I'm not accurate, but you get the idea of what I'm trying to go here, right, I think, right? Okay, so there's the angle of 7 pi 6. So what I do is, notice there's no such thing as a negative radius. So what I do is I stay on this line, and this line then becomes, when I go into quadrant 1, pi 6, doesn't it? Isn't that on the same thing? They're both equidistant away from the x-axis, 30 degrees or pi 6 radians. Would you guys agree with that? Okay, so you push through, and you would just go at the second radius, which is already on what we were at, huh? That makes sense. So let's do another example really quick on how you would do a negative radius. So if I had 3 pi fourths, comma, -3, how would I graph that? Well, my radius is 3, so there's 1, 2, 3. Everybody got that, right? Then we draw where 3 pi fourths is. Where's 3 pi fourths? Well, you guys agree that's 3 pi fourths? right? Half of that quadrant. So once again, but it's a negative radius, so what do I need to do? I need to extend this and push through to the other quadrant, the opposite quadrant, and make it on its third radius. So right there. If you ever have a negative radius, you push through the opposite and go into the opposite quadrant. Okay, so could somebody tell me what's another angle or another point that's exactly the same spot as 3 pi fourths comma negative 3? What would be the exact same point as that? 7 pi fourths comma what? It'd still be 3. Because if I was negative 3, what would happen there? I'd have to push through, right? So if I keep it as 3, it'll stay right where that's at. Does that make sense to you, Ambry? Has everybody got that? What's another way I could say it? Well, just switch the signs. Because isn't this part right here just negative pi fourths? Right? So that's negative pi fourths, comma 3 as well. I just made it into 2 different ways. I made the angle negative instead of the radius. How are we doing? Could we all graph something with a negative radius now? We hope so, right? So let's try one more. Should we try one more and let you do it on your own? Okay. How about, we'll make it easy on you. How about 3 pi halves, comma negative 2? We'll make it easy on you. That is so horrible. Okay. So, hopefully you've had time to already plot it because this doesn't take very long. I go to 3 pi halves. Oh, but my radius is negative, so what do? Push through and go to its opposite side and put it there. So that's equivalent to pi halves, comma 2. Would you guys agree with that? Those would be the same location. Or you could say negative 3 pi halves, comma 2. Because I would start here, go all the way around. Okay, do you guys feel like you could graph points using a radius and a theta? Okay, not too bad, right? Okay, now I would like to talk about how do I turn, kind of like in parametric, we were completely in, what was our beginning example? R equals 4 sine of theta, right? That's completely in polar, right? Completely polar, thetas and r's, correct? So I want to turn that into rectangular. What does rectangular have in it? X's and Y's. Well, let's learn about some stuff that we've already learned in the past. And we kind of touched it a little bit, not deeply, but we have touched it. Okay. On our unit circle, what is y equal to? Y equals to sine. Now, that's just on the unit circle. Because what's our radius on the unit circle? 1. Technically, this should be y over r is sine. Let me explain. Give me any point in the world. 5 what? 5/17. That was a little rude of you, but okay. So it's up here somewhere, right? Would you agree? I'm not going to do 17 marks. Okay. Well, notice this was 5/17, and then how would I find this value right here? Good old Pythagorean theorem. Oh, other way around. Sorry. Thank you. Seeing if you guys are on your toes. 17, 5. Oh my hell, BJ. Still seeing if you're on your toes. 5/17. Are we good there? Okay. Now we do Pythagorean theorem to find the radius, correct? 5 squared plus 17 squared. 17, I think, is 289. Plus that, so I think it's 316. 314, sorry. And I really don't want to break him down right now, because you guys should know how to break down square roots. You're in freaking 3 honors. You should know how to do that, right? Okay. I'm not going to worry about that. But what is the sign? It's the y value over the radius, isn't it? Do you guys agree with that? So therefore, would I not say that y equals r sine of theta? Could we say that? What do you guys think x is then? R cosine. Those are so important, guys. Go ahead and highlight that, box that, whatever you might need to do. Those are something you're going to need to memorize. Okay. Now, my question is, what is R? Well, something that I know is that we just did it right here. Isn't our radius squared equal to x squared plus y squared? Our x value plus our y value squared equals our radius squared. We just showed that, didn't we? By doing this triangle over onto the right. Can you guys see that? Because I took my x value, I took my y value, and I squared them. That equaled r squared, right? So that is also something that you'll need to know. R squared equals x squared plus y squared. All right. Ladies and gentlemen, I am so close up here. R equals 4 sine theta. Right? But what is that? What's missing in front of that sign that I can just say, oh, then it's y? It needs an r, doesn't it? Would you guys agree with that? So if I put an r right here, oops, I'm going to do a different color so you guys can understand it's new. R, what do I do to one side? I just can't throw an r on that side, can I? So what do I need to do to the other? Times him by r. So this is what I'll have. R times r is r squared equals 4 sine, r sine of theta. What do we know r squared is, ladies and gentlemen? We just mentioned it. X squared plus y squared. Did we not just say that? Right? Equals 4, what's r sine of theta? Y. You see how we got rid of the r's and the thetas? Yes, no, maybe so. Hey, I didn't like you chasing your brother just for some candied eggs. Okay, I saw that. You're a bit aggressive. Oh, yeah? Man, Easter Bunny likes you guys. My family just gets hard-boiled eggs laid around everywhere. 25 dozen we hid. Not just for my family, for my nieces and nephews. We eat them. What do you do with hard-boiled eggs? Why? They don't go bad, you find them all. Oh, we do. We don't. They can't look for their baskets until they get their eggs. Our eggs? No, we just lay them out. There's not the fun part. The eggs are like the least fun part. The basket is what's the legitness. On the ground, in the trees. We put them in a little egg crate. What do you guys? Hell no. Why would you do plastic eggs? This is Easter egg hunting. An egg, damn it. I know. Most everybody, and then we have, you guys find your Easter baskets like on your table or some shiz like that. I made two of my kids, the Easter Bunny made two of my kids cry finding their Easter baskets yesterday. One, it was a kayak in the shed. I made her get in she had to climb up a ladder into the kayak to get hers. It's okay if you don't celebrate Easter. I'm not trying to make you celebrate Easter. It's okay. Some people, I'd say, this is the other part. I'm going to push pause. I'm sorry. My oldest is 12. No, I think she does, yes. She's 10. My fourth grade teacher flat out told us. She almost lost her job. Nope, never okay. Hopefully at 17 or 16, you guys are okay. Anyway, now really quickly. Sorry, I know I get off topic and then make you come back, but you guys saw the graph that we graphed here. Right there. It was two back. It was a circle. Oh, three back. It was a circle, just shifted up. Could you guys agree with that? Okay, I'm going to show you because we did this equation right here. That 4 sine theta was this equation right here. X squared plus y squared equals 4y. Now, in the past, you guys have really only seen x squared plus y squared equals the radius, right? Now, you have seen it last year. You should have played around with this. You guys remember completing the square? That was a big thing you should have learned last year was completing the square. So it's really not too hard. Let's talk. X squared plus y squared. I'm just showing you, this is really where you need to stop. But I want to show you that it is in terms of a circle, right? Does that make sense what we just did? How many of you guys remember how to complete the square? What do I need to do? Does anybody remember? You take this value and what do you do to him? You cut him in half. Half of -4 is -2. -2 squared. Then we take that and we square it, and that's a +4. So can I just all of a sudden willy-nilly throw a 4 on one side of the equation? What do I have to do? Add 4 over here. So then I'm here. X squared plus y minus 2 squared. Because if I factored that y squared minus 4y plus 4, that would be a perfect square, a perfect binomial squared. That was the whole goal of completing the square, if you recall that last year. Okay, now notice, guys, where's our center? We've been doing centers with 0, 0. Where would our center be on this one? 0, 2 with a radius of, now does that make sense for what we just graphed? Right? 0, 2. Radius 2. That's basically what we had, right? Okay. So notice it's kind of like how we did parametric. We eliminated the parameter, except we were completely in polar, which is r thetas, and we got that out and just in x's and y's, right? Now, you're also going to get x's and y's in terms of polar, but that's not what we're going to hurry and concentrate on. Our next thing that we're going to do is I'm going to take a polar point, okay? So let's say I have the polar point. We always go r theta. Let's do pi thirds. I'm going to hurry and quickly graph that. Okay, that sucks. I know it does, but it's somewhere right there. That's the point, right? Now, what would that be in terms of rectangular, x and y's? Well, how can I get them that has an r and a theta in terms of x and y's? What have I already told you? X equals r cosine of theta. So do we know our radius? Yeah, it's right there. It's 2. Do we know what the cosine of pi thirds is? It's 1/2. 1/2 of 2 is 1. Does that look like kind of 1? It does, doesn't it? So 1, now how do you guys think I'm going to find the y value? Y equals r sine of theta. So I plug the r in, sine of pi thirds. So that's 2 times root 3 over 2, which is just what? Root 3, which is in between 1 and 2, huh? There's 1, there's 2. Is it in between there? Sure. Does that point represent the 0.2 comma pi thirds in polar, and then 1 comma root 3 would be a good coordinate for rectangular? So notice once again, what formula did I use? I used these two formulas to get me there. Okay? Everybody good with me on that? Okay, what if this time though I gave you a point? Okay, I'm going to make it nice on you, not like 517, you little stinker ant. I'm just playing with you. How about negative 3, 4? Okay, so we're going to graph that. 1, 2, 3, 1, 2, 3, 4. Now this time we're in rectangular and I want to go to what? Polar. Now polar, I want r's and thetas. Well, this guy's negative 3, this guy's 4. Is it pretty easy to find my radius? How do we find that? X squared plus y squared equals r squared, right? So in our case, 9 plus 16 is 25. That's r squared. Take the square root, 5. I gave you an easy triangle to do that, but I think we could find any triangle doing x squared plus y squared equals r squared, right? So far we have the radius is 5. Now I just need to find the angle. Correct? So if I'm sitting here, can I find any of the 3 trig functions? Sure, I'm going to go ahead and do tangent. Tangent of theta, because don't we always have y and x in tangent? That's why I'm using it all the time, because they'll be giving me an xy value, is equal to negative 4 over 3. Can somebody here take the arctangent of that for me, please? Negative what? 0.93. We'll just go 0.93. Negative 0.93. Now, where is negative 0.93? It's down here, right? Is that what quadrant I'm in? But that's our reference angle, isn't it? So therefore, this theta is negative 0.93. Or you could go pi, cut back that negative 0.93, right? So pi minus 0.93. And wouldn't I get the angle that I'm looking for? Can somebody do that? Go pi minus that answer? Because remember, this is down here and I'm up here. Somebody? Pi minus 0.93? 2.21. And that looks like a good angle, doesn't it? Out 5 radiuses at an angle of 2.21. Does that look equivalent? Okay, notice the 2 equations I used there was x squared plus y squared equals r squared. Oops. Oops, there it is. And tangent is y over x. That's what I used to find those. Your homework, ladies and gentlemen, is 1 through 31 odd 10-7. We did not finish this unit. We will be talking about it probably on Wednesday. If you are a sophomore, there's a good chance that you might be testing on Wednesday or Friday. I don't know which day yet, but it could be coming one of those 2 days. I don't have my